The Earth's population has nearly doubled in the last 100 years. Add climate change, lack of land to grow food, and overconsumption to the mix, and life as we know it on the planet appears to be impaired.
The new month claims tonight international vapour trails laid by international organisations could be filling central west skies with dangerous chemicals.
Especially mosquitoes that carry diseases like malaria and dengue fever. So we can use these same strategies, not just to control fertilization, things like insects, but also in humans as well.
Villagers in eastern India are sick from drinking contaminated water. It's a problem for many in rural India due to a lack of clean water.
Too many people consuming too much stuff. And we, the rich, consume far too much stuff. And yet people won't talk about it. And when did you last see an environmental trend, traffic, commodity prices, the price of oil, the civilization that resembles something that a type 2 civilization is stellar.
The only question is, can we make the changes necessary fast enough?
Imagine a world without boundaries in space or resources. This idea is easy to pursue if you go to Canada or Siberia, but not for long. Due to advances in modern medicine and the associated extended life expectancy, the world population has been growing substantially. As of this moment, there are 7.2 billion souls on Earth, adding 200,000 to it every day. It's only a matter of time before those countries will be full as well. Scientists believe that in 2100 we will reach the population capacity. 10 billion people will walk the Earth. Not all are as fortunate to live accordingly to the Western standards. The planet can only sustain 4 billion of those rich men. In this short documentary we will discuss and further divine the problem of overpopulation. Besides that, we might have found a very intriguing and much needed solution. Think of the colonization of North America in the 15th century, but then on a much bigger scale. Another place, unknown and strange, but similar enough to make it our new home. Mankind's final frontier. Space. Overpopulation means that the area cannot provide enough resources to the vast number of people in it. To comply to the bare necessities of life, the demand is bigger than what the Earth can provide. If we continue to live the way we do now, natural resources like water, oil and wood will finally run out. The battle for fresh water is already a big issue in Africa. Poor people simply cannot cover the costs of water, and the gap between the rich and downtrodden is getting bigger. This and the fact that people are also forced to live closely to each other, causing friction and irritations, can lead to major social tensions. But these social changes are not the only changes that occur. A strong growth in populace affects the Earth and her inhabitants in various other ways, such as on a physical, geographical, and demographical level. There is a discussion whether the growing population is connected with climate change, and in particular the greenhouse effect, pollution, and the heightened carbon dioxide concentration in the atmosphere. Changes in demographics will not go unnoticed. We are getting older, and at the same time the continuing population growth could result in one-child policies, or even having offspring at a later age. In 1979, China introduced the one-child policy. The purpose of this was to halve the population in one generation, but this brings forth another issue. The labor force, the actual number of people available for work, will be too small to support the economy in 2025. Another solution would be to stop vaccinating. People will be more susceptible to diseases, and epidemics will cause a natural outflow of our species. This idea is plausible, yet revolting. A third possibility to solve overpopulation is to expand the area we live in. This means we have to find new land to colonize, in this case, Mars. Mars is a rocky planet, and just like Earth, is located in the Goldilocks zone. This is a region around a star where planets have a sufficient atmospheric pressure and temperature to support liquid water at their surfaces. Due to the importance of water to life, these planets might exhibit extraterrestrial life, whether it's an alien life form or human pioneers. As of this moment, Mars does not support life. The air pressure is at merely 1% of that of Earth, and the mean temperature is minus 55 degrees Celsius. But as seen here on Earth, Homo sapiens can have a planet-wide impact. We can change the planet, making it a good, pleasant place to be. In order to do this, we need to understand the way the planet reacts to our activities. Building a closed-off system without interaction with the outer world would give us the ability to study the steps needed to colonize Mars. Texel, an island in the Wadden Sea in Holland, gives us a good place to build this complex. The complex consists of two enormous domes, connected by bridges. One dome is used to simulate Mars and how to terraform it. Terraforming means that the atmosphere is artificially adjusted to make it habitable for life. Before you do this on a worldwide scale, it's better to do this on a smaller, more controllable scale. Mars is about 1.5 times as far from the Sun as Earth, and is about half the size of our blue planet. Martian gravity is only 38% of what we experience right now. One day takes 24 hours and 37 minutes, and a year is 687 days. Due to the elliptic orbit around the Sun, the planet has very obvious seasons. If we want to colonize Mars successfully, we need to know what kind of impact these cycles of Mars have on Earth organisms. In the dome, we'll be able to control the day and season cycle, but unfortunately not the gravity. The other dome is to simulate Earth. This dome is completely self-sufficient and does not require anything from the outside to operate. Eventually, this building can be transported to or be built on Mars. There has been previous experiments to simulate Earth, such as the BIOS 3 and the Biosphere 2. The BIOS 3 was built in Krasnoyarsk, Russia. It was only 315 square meters and could support 3 people. There were 4 compartments, 1 living quarters, 1 algae cultivator and 2 vitrines. Vitrines are areas where crops could grow, and the algae was used to recycle the air. The whole complex reached an efficiency of 85%. The Biosphere 2 is a facility of the University of Arizona and is currently used to research ecosystems. With almost 2.5 acres, this complex can support 8 people and features 2,500 square meters of agriculture, 1,900 square meters of rainforest, 1,400 square meters of desert, 1,300 square meters of savanna, 850 square meters of ocean with a coral reef, 450 square meters of mangrove, and sufficient space to live. This facility was also used to research space colonization. In order to have a facility on Mars, it must meet certain requirements to withstand a hostile environment. Vacuum, high solar radiation, and extreme temperatures exhibit forces on the edifice. Inside, there's a system that regulates the atmosphere and circulates the air. Food and water are produced and recycled. The facility must be big and efficient enough to sustain a large amount of people indefinitely. 95% of Mars' atmosphere is carbon dioxide, but even more of this carbon dioxide is stored in the southern polar cap. The temperature there is currently minus 126 degrees Celsius. If the temperature is increased by 4 degrees Celsius, this carbon dioxide will be released. Due to initiated greenhouse effect, this temperature will continue to rise. Eventually, the whole polar cap will melt and the pressure would increase to about 30% of that of Earth. This is enough for people to go out and walk the planet without any special kind of suit to endure the pressure. There are a couple of methods to warm the planet, but only 3 of them look promising. The first one is to build a mirror in space. With a diameter of 125 kilometers, this mirror will reflect sunlight to the southern pole. The second method is to find asteroids that are rich in ammonia. The idea is to redirect these and let them crash onto Mars. Ammonia is a strong greenhouse gas. It should induce a rise in temperature. The last solution is one we're very familiar with, a method we're actually using right now: factories. But then the factories on Mars will produce greenhouse gases as their main product. The atmosphere is now warm enough to support liquid water, but this is not enough to have plant life. A lot of nitrogen is still trapped in ice. But once all that ice melts, and a lot of nutrients have been added to the atmosphere and water, plant life can finally begin and generate oxygen. Humans are social animals. We build our lives around interactions with other individuals. Living in an isolated system with limited variety in interpersonal relationships can cause a severe strain on our mental well-being. Loneliness, fear, paranoia, and depression can wear a man down. Traveling to Mars gives rise to problems as well. Depression too, but also insomnia, agitation, anger, and a decrease in performance. All this needs to be studied in the TESOL program, so the colonization mission can be adjusted to minimize these social effects. But during this investigation, the test team will have little to no privacy, as everything is recorded and documented. According to experiments in Antarctica, a mixed crew of different cultures and origins works the best. The crew needs to understand the design and construction of the whole mission. They need to know they can expect psychic and physical changes, and they need time to adjust to it. They need to work very hard, but also get enough time to relax the mind. Selecting the right people is crucial for the success of the expansion of the human empire.